This is a continuation of part 1 logistic regression. In part 1 we observed that when y is an indicator variable, then epsilon I, the error component, takes only two values, that is that is 1 minus xi prime beta curl or minus xi curl prime beta curl. This is happened when y equal to 1, yi equal to 1, and this is happened when yi or y equal to 0. So we conclude that when y is the indicator variable, then epsilon I cannot be assumed to follow normal distribution. This is the first thing which we observed in our first logistic regression video, part 1. This thing we observed. Next, we observe that when y is the indicator variable, then variance of yi equal to pi I 1 minus pi I. This depends on yi. This depends on yi. Moreover, since expectation yi equal to pi I, and pi I is a probability of yi equal to 1. So expectation of yi lies between 0 to 1. This puts a big constraint on the choice of linear response function. So we cannot fit a model in which the predicted values lies outside the interval of 0 and 1. So first we observe this, that is, when y is the indicator variable, then epsilon take two values. So in this case we cannot assume epsilon follow normal distribution. Second thing we observe, variance of y is a variance of y depends on yi. And third thing, most important thing we observe, since expectation of yi equal to pi I and pi I is a probability of yi equal to 1, therefore expectation of yi lies between 0 to 1. So we cannot fit a model in which the predicted values lie outside the interval of 0 and 1. These three things we observe. When y is a dichotomous variable, then empirical evidences suggest that the function expectation y on the whole real line map to closed interval 0, 1 has the sigmoid set. Sigmoid function is a mathematical function having a characteristic S-shaped curve, S-shaped curve or sigmoid curve. A common example of a sigmoid function is the logistic function. So the standardized logistic function sigma map from whole real line to close interval 0 to 1, or it is better to write open interval 0 to 1, is defined as sigma t equal to e to the power t by 1 plus e to the power t equal to 1 by 1 plus e to the power minus t. And if we plot this function, then it look like this. This is a S curve So, in particular, expectation of y equal to exp x curl prime beta curl 1 plus exp x curl prime beta curl. Now if we take one explanatory variable, then we see that this is nothing but a this. Here we use, suppose we use one explanatory variable. Then first we take beta naught equal to -4 and beta 1 equal to 0.8. Then we see that the curve look like this. And if you take another set, beta naught equal to -4, beta 1 equal to -0.8, then this curve look like this. So that means if we take beta naught any real value and if we take beta 1 greater than 0, then you get this curve. And when beta belonging to any real, beta naught is any real value and beta naught is any real value and beta 1 less than 0, then we get this curve. You can check this via a simple R code. Suppose I take value of x -15 to +15, and the increment is beta naught or here I denote it B naught for beta B1 equal to 0.8 P equal to exp B naught B1 x 1 plus exp B naught B1 x. Now plot x and p, where x is in x-axis, p in y-axis. Type L for line, x lap y lap within inverted comma please you write this in a single line, then you see that your curve look like this. And if you change this value of B1, that is beta 1, I denote B1 here by beta 1 by B1 here. Now we change the value of B1. Now B1 equal to minus 0.8. Then you see that the curve look like this. Now consider linear predictor and link function. Linear predictor means the systematic component in expectation of y is called linear predictor. and it is denoted by eta I xi curl prime beta curl I from 1 to n, where xi curl is a vector of k explanatory variable. Since here we consider k explanatory variable, and beta curl is not all xi curl k explanatory variable along with 1, that is 1 x1 x2 xk. This 1 correspond to intercept term beta naught, beta 1, beta k, and link function a map or link function maps the range of mu I onto the whole real line. Provides good empirical approximation and carries meaningful interpretations in real applications. So link function maps the range of mu I onto the whole real line, provides good empirical approximation and carries meaningful interpretation in real applications. So, in other words, the link function provides the relationship between linear predictor and the mean of the distribution. So, linear predictor is a systematic component in expectation of y, and it is denoted by eta I, that is equal to xi curl prime beta curl, and link function maps the range of mu I onto the whole real line. So, we denote the G mu I equal to eta I, and this imply mu I equal to G inverse eta I. So this is the link function G mu I. So G mu I equal to eta I, and therefore mu I equal to G inverse eta I. If the linear models are based on normally distributed study variable, so for normal distribution, the link function G mu I is simply mu I, and it is called identity link. In case of logistic regression, the link function defined as log pi 1 minus pi, where probability y equal to 1 equal to pi. This transformation is called logic transformation, of probability pi and pi by 1 minus pi is called odds. So the link eta, is also called log odds. This link function obtained as follows. Pi, which is expectation of y, is equal to 1 by logistic function. We already discussed this. So expectation of y equal to pi equal to sigmoid functions. So we take it this. Here we mention one thing. The natural choice for expectation of y would be the CDF of a random value. In particular, the logistic distribution whose CDF is the simplified logistic function yields a good link and is given by this. So pi equal to 1 by 1 plus exp minus eta. So this implies eta equal to log pi by 1 minus pi. Note that similar to logit function, there are other functions also which have some shape, which have same shape. So similar to logit function, there are other functions. I repeat this again. Similar to logit function, there are other functions also which have same shape as of logit function. Thus functions can also be transformed through pi. There are two such popular functions, that is probit transformation and complementary log-log transformation. The probit transformation is based on the transformation of pi using the cumulative distribution function of normal distribution, and based on this is called probit regression model. And the complementary log-log transformation of pi is log minus log 1 minus pi. So I repeat this part again. Similar to logit function, there are other functions also which have same shape as of logistic function. These functions can also be transformed through pi. There are two such popular functions, probit transformation and complementary log-log transformation. The probit transformation based on the transformation of pi using cumulative distribution function of normal distribution, and Based on this is the probability regression model, and complementary log-log transformation of pi is log within bracket minus log 1 minus pi. So next video we will continue the logistic regression, and in the next video we will discuss maximum likelihood estimator and interpretation of parameters of logistic regression. Thank you.